Okay, we will go through some important point in the class 12 chemistry chapter 12 aldehydes, ketones and carboxylic acids. Organic compounds containing carbon oxygen double bond is the carbonyl group. Aldehydes, the carbonyl group is bonded to a carbon and hydrogen. In aldehyde, it is bonded to a carbon and hydrogen, but in ketones, it is bonded to two carbon atoms. This is aldehyde. Here one carbon, one hydrogen. Here two carbons, one carbon, there is one more carbon. This is ketone, carboxylic acid. So from here, if you add one more oxygen, then it will become carboxylic acid. If you add one more oxygen here, then it will become the ester. Okay. See here, this is the difference between ester and ketone is the one more oxygen is here. Okay. Used in many food products and pharmaceuticals to add flavors. This aldehydes ketones. How to name the aldehyde ketones? Okay. The aldehyde. What is the alpha hydrogen? Okay. This is the functional group aldehyde. Is connected to the carbon chain. The first carbon is the alpha carbon. The hydrogen attached to this carbon is alpha hydrogen. Okay, alpha hydrogen at here beta gamma. This is acetone dimethyl ketone. This is benzophenone, two benzene rings and then the carbonyl group benzophenone. This is IUPAC name. Last AL means aldehyde, ONE means ketone. So here they are given. AL and ONE. This is the common name formaldehyde. This is acetaldehyde. IUPAC name methanol, ethanol. See the carbonyl carbon carbon in the carbonyl group is sp2 hybridized because of the double bond here between the carbon and oxygen is sp2 hybridized bond angle 120. Here we have 3 sigma bonds, 1 pi bond. Pi bond is between carbon and oxygen, 1 sigma bond between carbon and oxygen and 2 sigma bonds between the carbon and to carbon. So there are 3 sigma bonds, 1 pi bond. So this double bond is polarized because of the electronegativity of the oxygen, electronegativity difference between the oxygen and the carbon. Partial positive for oxygen, partial negative for oxygen, partial positive for the carbon. So carbonyl carbon is a electrophile, so it loves electron, and the carbonyl oxygen is a nucleophile, it loves nucleus. The high polarity of the carbonyl group is explained on the basis of the resonance involving neutral. This is a neutral A and bipolar, dipolar. This is the polar and this is the neutral. How to prepare aldehydes and ketones? Okay, this is in some other chapter. There is unit 11. So while going through that chapter, we can see how it is aldehyde ketones are prepared from the alcohol. Hydration of all kinds. Addition of water to ethane in the presence of gives acetaldehyde. Only ethane gives the aldehyde, but all the other alkynes they give ketones. Okay, that is important. Only ethane gives the aldehyde, all the other alkynes gives ketones. Barium sulfate, BaSO4. This is a Rosmond reaction. This named reaction you have to remember. Stefan reaction. Third reaction, formation of the aldehyde, benzaldehyde. From toluene, how benzaldehyde is formed by this reaction. Here also benzaldehyde. Gatram and Gauch reaction for the aldehyde. Ketone preparation. So this is the Grignard reagent or MgX. This is the Grignard reagent. Okay. From benzene. This is called Friedel-Crafts alkylation reaction. So preparation of ketone from benzene. The benzyl chloride and it is AlCl3 and it is aluminum chloride. Methanol is a gas at room temperature. Ethanol is a volatile liquid. Other aldehydes and ketones are liquid and solid at room temperature. These are the boiling point and molecular mass comparison. More molecular mass, boiling point increases. Length of the alkyl chain increases, then the solubility decreases. See, aldehyde, between the aldehyde and alcohol, the alcohol has a OH group, hydrogen bonding, intermolecular hydrogen bonding. So this boiling point will be more than this aldehyde, because here there is no intermolecular hydrogen bonding. Nucleophilic addition reactions. Contrary to the electrophile addition reactions observed in alkenes, electrophilic addition reaction in alkenes, aldehydes keto undergo nucleophilic addition. Okay, alkenes, that is also having a double bond, that is electrophile, but aldehydes and ketone nucleophile, because of this polarized carbon and oxygen bond in the aldehydes and ketones. So this is a nucleophile. Here how nucleophile is formed, intermediate nucleophile how is formed. Nucleophile attacks electrophile carbon of the polar carbonyl group. Because of this polar nature, this is acting as a nucleophile. Reactivity. Aldehydes are generally more reactive than ketones due to the steric and electronic reasons, because ketones have more methyl groups. What would you expect benzaldehyde to be more reactive or less reactive? The nucleophilization to propanol. Okay, benzaldehyde, this is aromatic aldehyde, and this is aliphatic aldehyde, propanol. Explain the reason. Because of this resonance, the aromatic aldehyde is less reactive than the propanol, that is aliphatic compounds. Carbon atom, the carbonyl group in benzaldehyde is less electrophile than the carbon in the carbonyl group present in the propanol because of this resonance. Okay, benzaldehyde resonance, that is why it's less reactive than the propanol. Hemiacetal, acetal, hemi, only one methyl group, acetal, two methyl groups attached. Carbonyl derivative product name. Reduction, aldehyde ketones are reduced to the primary secondary alcohol on reduction. Reduction to hydrocarbons. Okay, in the presence of the zinc amalgam and the concentrated hydrochloric acid, this is called this Clemmensen reaction. Reduction to hydrocarbons. Kirchner reduction. Tolerance test, this is for the aldehydes only. The tolerance reagent, ammonical silver is the tolerance reagent. Bright silver mirror is produced due to the formation of the silver metal. Okay, and these findings, this test for aliphatic aldehydes only. This is not for the aromatic aldehyde. This is not for the ketones. Ketones and aromatic aldehyde do not respond to this test. Okay, this is for the aliphatic aldehydes only. Aldehydes and not aromatic aldehydes. Holoform reaction. This is aldehyde ketone with one methyl group, only one methyl group. Okay, like this methyl group. Form iodoform. CHX can be CLI, so this can be iodoform. If it is I, it is iodoform. One carbon less than the carbonyl compound. From here, this product has one carbon less than this reaction. If a compound gives this test, therefore it is aldehyde or a ketone. Since it does not reduce Tollens or Fellings reaction, then it is a ketone. Okay, because aldehydes reduce this Tollens and Fellings reaction. A is respond to iodoform test, therefore it should be a methyl ketone. Okay, methyl ketone, because iodoform is methyl group attached to aldehyde ketone, so it is methyl ketone. Ketone to iodoform. Reaction due to alpha hydrogen. The acidity of the alpha hydrogen atom, the carbonyl compound, is due to the strong electron withdrawing effect of the carbonyl group and the resonance stabilization of the conjugate base. Okay, because the electron is withdrawn from the alpha carbon, so the alpha hydrogen is more acidic. Aldol condensation, aldehyde ketones having at least one alpha hydrogen atom. Okay, at least one alpha hydrogen, then only this it will undergo this reaction. So it has one alpha hydrogen atom here. Cross aldol condensation. When aldol condensation carried out between two different aldehydes or ketones. Okay, these two different aldehydes, or it can be ketones, then it is cross aldol in the presence of NaOH. Okay, so aldehydes do not have an, you see here the aldehydes do not have alpha hydrogen. This do not have the alpha hydrogen. Okay. This also do not have the alpha hydrogen. The functional group is called as carbon which do not have the alpha hydrogen. Carboxylic acid, COH group. Fatty acids. Nomenclature of the carboxylic acid is a formic acid. This is formic acid, acetic acid. Okay, methanoic acid, acid is IUPAC names. Carbonyl group. Carboxylic carbon versus the carbonyl carbon. In carboxylic acid, the bonds to the carbonyl carbon lie in one plane and are separated by the 120 degree. Carboxylic carbon is less electrophile. Carboxylic carbon is less electrophile than the carbonyl carbon because of the possible resonance. Okay, this is carboxylic carbon is less electrophile than the carbonyl carbon because of this resonance. How to prepare carboxylic acid from alcohol? This is a Grignard reagent or MgX. From this, how to prepare this carboxylic acid? This is one carbon more than the parent. From esters, how to prepare carboxylic acid? Carboxylic acid have intermolecular hydrogen bonding. Stability decrease, solubility decreases with increasing number of the carbon atoms. Acidity. Carboxylic acid dissociates water and leave the resonance stabilized carboxylate anion and hydronium ion. Okay, this is the resonance. This resonance is a equivalent resonance because charge changes between the oxygen atom only. Here oxygen between the oxygen atom only. This is equivalent resonance. So how to determine the acidity? This is acid dissociation constant based on this pKa values. Strong acid means its value is less than 1. This is the difference between the carboxylate ion and the phenoxide ion. The conjugate base of the carboxylate acid is a carboxylate ion is stabilized by two equivalent resonance structure in which negative charge. In the carboxylate ion, the negative charge is between the more oxygen atom. The conjugate base is phenol. The resonance is between the carbon and the oxygen atom. Okay, the carboxylate, the resonance, the charge changes between the oxygen atoms only, but in phenoxide, during resonance, the charge changes between the carbon and oxygen. So in phenoxide, non-equivalent resonance, carboxylate ion, the equivalent resonance. The negative charge is delocalized over two electronegative oxygen atom in the carboxylate ion, whereas it is less effective delocalized over one oxygen atom and carbon atom in the phenoxide ion. So carboxylic acid is most acidic and more stable than the phenoxide. Electron withdrawing groups increase the acidity of the carboxylic acid. Electron withdrawing group increases acidity. Electron donating group decreases the acidity. This is how the acidity varies. Okay, so here this is more acidic than this. This is more acidic, more stable than this compound. More acidic means more stable. See this. This is more acidic than this. Electron withdrawing group and the aromatic aldehyde increases the acidity. This is ester. Carboxylic acid to the alcohol on reduction. Decarboxylation. Halogenation. This is the okay, you can go through this summary.